Looks like you made it. If you're watching this, you survived your first exam. And you're messing with limits. It's going to go down a bit. And I know limits are weird. The limits are going to start to kind of go away for a little while. They're going to be back, and like actually pretty soon, but much less. We're going to start shortcutting. All the stuff we're doing in 2.7 and 2.8 with that limitization tends towards 0 stuff, that's going to start to go away, but not in this video. It's actually kind of all about that, but it's going to allow us to shortcut everything, and that's freaking great news. We want a shortcut. Let's go. So let's assume we have some function and it's equal to a constant. So maybe like y equals c. Like, so maybe you don't like that. You're like, well, I don't know. Not like maybe you're just going through it like 4. You know what I mean? Like maybe it's just some freaking number, some flat line. Who gives a shit? All right, going back. We're not calling that 4. We're going to call that c. So what's the slope of the line? Because we're going to talk about the we're going to talk about the derivative. We're going to talk about the derivative. Remember this thing? F prime of x. We want to know what's the derivative of that function. But really, what does it solve for? It solves for the slope of the tangent line at any given point. So we're like, well, what's the slope of this line? That's just flat. It's flat, right? Put a ball on top of it, it's not gonna roll off the top of a table. It's flat. There's no slope. So we know the answer is gonna be frickin' 0. All right, let's go. So now we got to take this. What's the formula? You know what? Let me write it in real quick because I'm going to use it a couple times and I'm not going to actually write this over and over. But hey, that's what we're solving for. So we're like, all right, well, let's go find f prime of x. Let's go find this one. We're looking. We just want to see for this constant here. So the way this thing works is, when we go to plug into our f of x plus h, we go put in the limit as f of x plus h. We're just anywhere we see our x, we just plug in x plus h. So we look over here and we're like, anywhere we see an x, there's no frickin' x. See what f of x plus h is? The height's frickin' c. I don't give a shit what you plug in. The y value, the f of blah, is frickin' c. I don't give a shit if your x is right here, your x is right here. Who gives a crap? The height is c. So then when we go to subtract out our f of x, we're like, well, that shit's c too. And what's the same thing minus the same damn thing? We got the limit as h tends towards 0 of 0 over h. The limit as h tends towards 0 of 0. That shit is 0. So there we have it. And I'm going to write this in Leibniz. Well, first, I'm just going to write it up here. Say f prime of x is equal to 0. So if you have a constant, its derivative is 0. But I got to write it a little crazy. Let's get weird. This is Leibniz notation. The next one I'll show it as well. And we're going to write it in as the derivative of a constant is equal to 0. That's how I just wrote both of these things. Kind of where Leibniz notation might be a little superior. You know what I mean? I'm talking about a lot of information with less writing. And in math, that's always what we're looking for. Less writing, get her done. Let's go to our next. Now we're going to try and find the slope of the line. Find the derivative, which is just going to tell us the slope of that line. The slope of that line is 1. The answer is freaking 1. Yeah? You agree with me? The slope of that line is 1? I hope so. Oh, let's get it. We want to go get our f prime. So f prime of x. Oh, corrupted. Love it. All right. So the limit is h tends towards 0. And we got to put it in. So, all right. So instead of writing f of x plus h. So instead of writing x, we're going to write x plus h. Then we're going to subtract out, and we're going to subtract out f of x. Well, f of x is right in frickin' front of us. We'll go like that. Let me slap it over h. And all these derivatives are pretty frickin' straightforward. They don't get much more straightforward than this. Look, I don't even need these frickin' parentheses. Shit just goes away. So we have the limit as h tends towards 0 of, I think we have an h up top, and we have an h down below, and I think that's 1. You know what I mean? And then we use that constant rule and being like, the limit is h tends towards 0 of 1. There's no freaking h's, so ignore the damn 0, and the answer is 1. Therefore, the derivative of f of x is equal to 1. Surprise, surprise. And I know it's freaking fascinating stuff figuring out how to find the slope of a line that you already knew the answer to. Watch me do a proof about it. But it is what it is. It's just good to know all this shit. And we write it in Leibniz and we can say, hey, if you want to take a derivative with respect to x, that's what it's saying, d over dx. If you want to take a derivative with respect to x, saying that's the freaking variable of x, that shit's 1. Shorthand. It's nice. 2 different notations to say the same thing. What do you like better? All right, now the next one. This one's a little more work, but this is going to open up doors. This is going to open up some friggin' doors. We're going to look at the derivative as x tends towards n. Or, shit. We're take the derivative of x to the power of n, where n is any real number. So, like 7. Maybe we want to find the derivative, or like, what's f of x is equal to x to the 9th? Or maybe a cube, or a square, or something. Like, that'd be kind of cool to be able to figure out what the derivative is. Like, what's the slope of the tangent line anywhere for an x cubed, or being able to do something to the 4th. Maybe this is to the 4th. Maybe it looks like this. Maybe you got some other bullshit back behind it. I don't know if that's just talking shit, but you can find the slope of some stuff, the slope of the tangent line, just by hitting it with this little power rule. And the power rule's dope. Shit, I could have taught you power rule first day. It's easier than any freaking limit. The proof? Not so much, though. Proof's pain in the ass. Good thing this is not a proof writing class for y'all. This is not a proof writing class. You're not required to do this. I am. I'm a teacher. If you're a math major, later, you'll have to do it. Like the shit I had to do when I became a teacher. So you don't have to do this. You can turn this off if you want to. But here it comes. Now we are going to write this as the derivative of prime of x is equal to the limit as h tends towards 0 of our f of x plus h, which is just going to become x plus h raised to the power of n, minus f of x, which is x to the n, all over h. Cool, no problem. What's n? How you gonna expand that shit out, huh? What's up? Did you have a badass teacher? I hope you had a badass teacher. I hope you had, like Professor Newsom or Professor Balaga, where I know for sure they taught you this. It's called the binomial theorem. Now I'm gonna write it in a terrible way, and we're not gonna really need to not talk about this symbol too much till the end of the course. I'm here to scare you. This is the proof one. So again, if you want to just get out of here and stop watching this, go for it. This is for interested students, A students, math majors, stuff like that. If that's not you and you don't want to follow the recipe, you go to the next one where we'll just talk about what the power rule is. I'm going to tell you, because I'm going to drone on for the rest of this. I'm not going to drop a quiz or anything, so don't stress about that. This thing is equal to the sum is, maybe say k is equal to 0 on up to n of n choose k. You know what I mean right there? N choose k? Yeah, you got that, huh? And then we say it's x to the k, clearly. Oh, and then it's going to be, that's going to be h raised to the n minus k. Clearly, right? Clearly. Even if you had one of those badass teachers, I don't know whether you would have saw it like that for much more than a second, or whether it even stuck with you long enough to just, I learned it for long enough to pass a test. But let's just kind of, I'm just going to give you the first few terms, because I don't want to go into this n choose k. That's like I learned that shit in like probability, statistics, things of that manner. It's kind of a cool formula sitting here. There's so much power to this freaking formula. But hey, no math nerding. Okay, let's go. Let me just give you the first few terms. X plus h to the n. If we were to break this thing down, you're going to get x to the n, and then you're going to, it's going to be with n, x to the n minus 1. I'm going to need a little room over here, so hold up. Times h plus, that's to the first, that's how that formula works, and then we're going to have n times n minus 1 over, clearly, right, you know this, huh? X to the n minus 2 times h squared, stop it, plus, and then dot, we keep going, and let me just write in the last couple terms because you know it's no big deal. Plus h to the n. Cool. So that, I mean that's just written out. So I mean if this part didn't make sense to you, like I mean come on, doesn't this make? Of course not. There's a lot of shit written in there. Basically, like, if you learn how to do the binomial theorem, you pretty much just caught a pattern, maybe not this whole formula. And to tell you the truth, I actually have to look this shit up. I don't fill all my brain space with this. I mean, it's kind of a lie. I mean, I can do it, but I check it because I don't have this on lock. So basically, here's the game. This thing's gonna work out, and we plug all of this. Oh my gosh. Oh nope. I need a longer line. I don't like that line. Let's do it like this. Let's take a longer line. Well, we need to plug in f of x plus h, but I actually kind of just, do you mind? I just did it right here. I'm gonna just cheat and take this out and be like, why don't you travel right there? So I don't have to rewrite all this stuff. You know what I mean? So there's our f of x plus h. And we continue this thing out, and now we got to take away our f of x, and we got it all over h. Sorry about that. I didn't want to write that again. Now what's going to end up happening is we're going to lose these. We're going to lose these, which is good news. That's good news. Everything with out an h on it went away, just like from before. So if you're still following along, good on you. Now we want that h to go away, so we're going to have to factor an h out from every freaking term. Every term. But really, the only thing we're going to care about, because h is, like, I'm going to just kind of jump to the point. H goes to 0. Well, let's look. I'm going to cheat here and be like, since these two are going to go away, like, we're going to lose a power, we're going to lose a power, there's going to be n minus 2, there's going to be n minus 1. We're going to lose a power when we do this h trick. The only thing that's going to be left is this. That's not going to have an h on it. And we're going to take h to 0. So all of those other terms are going to go away. And I'm just going to jump it in so you don't have to actually watch the whole thing. But that's the game. It's just going to pop out n times x to the n minus 1. Really just talk to you more about the fact that, do you know the binomial theorem? Calculus is like this. You're supposed to know all this shit. You're not supposed to necessarily know how to do this proof, but you're supposed to know the binomial theorem. Or at least how it works out. So there's lots of challenges, and I thought, what the hell? Let's be rigorous. Let's put it through, even though I didn't even rigorously go through and finish this. I don't want to write it all out. It's more of a scare tactic more than anything, but your job as a calculus student to know if that's the derivative, if that's the function, here's its derivative. And we could also write it in with that Leibniz notation saying, if you want to take the derivative with respect to x on x to the n power, it's going to be, hey, let the power fall to the front and multiply it and take one away from it. Hey, next video, I'll make sure to show you how and not all this why. So, see you in the next.